SK Pass International College. We are still on chemical bonding. But before we continue, I will invite you to like this video, share and comment. If you have not subscribed to this channel, please kindly subscribe so that anytime there is a new video on any topic, you will get access to the video. Thank you very much. We are still on chemical bonding, and today we are going to look at another interesting aspect of the chemical bonding. Already, if you have not watched the previous video on covalent bond formation and using the Lewis dot structures and drawing the various molecules, kindly do that. In today's video, we are going to concentrate on an interesting aspect of chemical bonding, which we will be looking at some covalent characteristics or ionic characteristics in covalent compounds. So, and anytime there's an ionic compound, there is some nature of covalency in that ionic bond. That is basically what we are going to look at. So, for instance, in our previous video, we said that this sodium chloride is an ionic compound. Ionic because of the polarities. This is positively charged, negatively charged. The force of attraction existing between this is an ionic bond. However, this sodium chloride is not 100% ionic. There is no compound which is 100% ionic. So, a situation whereby there is an introduction, some characteristics of covalency in ionic bond will lead us to a concept which we call polarization. So today we shall be looking at polarization. And when you have a molecule like this, in our previous studies we also said that this is also another aspect of, or this molecule we can see is a covalent molecule. Why is it covalent? We already said in our previous video that in covalent molecules there is sharing of bond pair electrons. They share the electrons. And this particular covalent bond is a polar covalent bond. Polar in the sense that there is an unequal sharing of these bond pair electrons. So anytime you have a covalent molecule like this molecule is not 100% covalent. There is some ionic character in this covalent molecule. So a situation whereby there is some covalent nature in an ionic compound, that will lead us to a concept called polarization. And anytime there is some nature of, this is a covalent compound, a covalent molecule. But anytime there is some nature of what? Ionic character, that leads us to another concept called dipole moment. So in this video, we are going to explain the concept polarization and then dipole moment. So let's take the first one. So in a very simple context, anytime there is polarization, it means that there is some covalent characters in an ionic bond. Okay. So one thing you have to notice is that anytime I talk about polarization, it means there is some covalent characters in an ionic bond. So for instance, look at this sodium. This is sodium and this is an chlorine. Now you realize that these two molecules, just like we said, they are already ionic, but not 100% ionic. There is some sort of introduction of covalent nature in this ionic bond. So what is really going to happen? You realize that this chlorine has what we call an electron cloud. So this chlorine or the anion has something we call an electron cloud. So this is the electron cloud. And this is the cation of this sodium. Now, we realize that for these two to come together, because of their polarities, there will be some sort of attraction. It's like putting a magnet and a magnetic substance together. There is an attraction. So what is happening here is that the process or the act of the distortion, when you say distortion, is a disturbance. The distortion of this electron cloud of this anion by this cation is what we term as polarization. So someone will say, then how do you put this context? Or how do you explain the concept polarization? Polarization can just be defined as the process whereby, or is the distortion, you can just say it is the distortion of the electron clouds of the anion. So it is the distortion So in a very simple context, if you are asked to define polarization, you can just put in a very simple context that it is the distortion of these electron clouds of the anion by the cation. So who is doing the distortion? The distortion is being done by the cation. It's just like you putting a male and a female in a room. The lady will be feeling shy, as if the person, I don't like what you are doing. This man will cause some reaction to occur. So before anything will occur, it is this man who will cause the whole thing. And it's this man who will make this female distorted. So that is the concept. Polarization, what it means that in this ionic compound, we have introduced some covalency. Covalency, we will look at a rule governing this called the Parsons rule, which will help us to understand the concept in a detailed way. So, this polarization has some terminologies that you need to understand. This is the whole process. The process itself is what we call the distortion of the electron clouds by the anion by the cation. But under this polarization, we have some terminologies like polarizing power. What do you mean by polarizing power? Now, the ability of this cation to pull the electron clouds of the anion towards itself. The ability of this cation to pull the electron clouds of this anion towards itself is what we call polarizing power. So when you say polarizing power, this cation will pull the electron clouds onto itself, will pull it. So in a very simple context, you can say polarizing power, it is the ability So, polarizing power is the ability of this cation to pull the electron clouds towards the electron clouds of the anion towards itself. That is what we call polarizing power. So, since the cation has been able to pull this towards itself, then there is something that will happen automatically. Since you are forcing me to do the thing and I'm not interested in doing anything, then it means that I have to accept whether I like it or not. So this anion will also say, if that's the case, I'm even fed up, then whatever will happen, let there be a reaction. So the anion will also move towards the cation. In this case, so this polarizing power is normally done by the cation. Who does it? Is the cation. the cation that is in charge. But when it comes to polarizability, in this case too, it is the ability of the anion or the electron class of the anion to what? To move towards the cation or to go to the cation. So are you seeing the difference? Here, it is this cation that is pulling the electron class towards itself. That is called polarizing power. But in terms of polarizability, it is the ability of the electron clouds of the anion to what? To move towards the cation. So that is what is happening. One thing we need to understand is that polarization this polarization we are talking about, the more polarized a molecule is, anytime we have a molecule and it has a lot of polarizing power, it makes that molecule weak. Okay? The more polarized a molecule is, it makes that molecule very weak. So, for instance, if I have sodium chloride and then cesium chloride, I can ask you to determine which of these is more polarized, or which of these will contain a higher polarizing power, or which of these is having a higher polarization. In this case, how do you determine that? We determine this with a concept we call the Farzing's rule. So we will look at a rule called the Farzing's rule, which will enable us to know how to classify these molecules into which one has a higher polarizing power and which one has a lower polarizing power. So polarization is directly to covalent polarization is directly to what? Covalent nature. Anytime the polarization is high, it's directly. It means there's more covalent character in that ionic molecule. But polarization is inverse to ionic molecule. Here, when the polarization is less, it means that the ionic character in that is also less. So the higher the polarization or the higher the polarizing power, the less reactive or less the sodium chloride or the covalent nature in that molecule. One thing we need to note is that. So for instance, let's come back to the question. Sodium chloride and cesium chloride. Which of these two will have a higher polarizing or polarization? With this one, you can attest to the fact both of these, they are all having chlorine. So our emphasis is going to be based on sodium and cesium. Okay, so sodium and cesium is going to be our comparative or the one we are going to use in comparing. Apart from this sodium and cesium, here sodium and cesium, which one is bigger? So the rule we are going to learn is Farzing's rule. What Farzing is saying is that for polarization to occur, there's one thing we need to know. It says that the cation should be smaller in size and the anion should be bigger in size. So what he's saying is that this cation should be smaller in size and this anion should be bigger in size. That is one of his conditions. And the second condition is that the bigger the cation, the higher the polarizing power or polarization. So when you are more polarized, it means you are weaker. So looking at these two, in our next video, we are going to explain which one will have a higher polarizing power. So subscribe to the channel